Hello guys, this is Daniel. Welcome to another video in our series of blockchain tricks for the Python geeks. Today we're going to talk about Web3 transactions. We call them blockchains because they are made of blocks. Each block contains several transactions, and the transactions as well are divided into several elements. The most important elements are the sender and nonce, which is a method that Ethereum has to avoid double spending. It's just a correlative of the transactions that have been originated from a specific Ethereum address. You have the receiver public address, and you have the amount. Those are kind of like the core of your transactions. Of course, these transactions have to sign, and that is the function of the private key of the account that you are sending the transaction from. It's such a security method as a password, so all of those have to be stored very securely. These are the elements of the transactions, and today we're going to learn how to play with this in Python. Today we're going to be using Ganache. Ganache is a simulator of an Ethereum node that runs locally. It runs locally on this address that we have here, so that will be a node provider for this session and the further sessions that we're going to have down the line, because starting from this video we're going to be doing transactions either as pure transactions and then interacting with smart contracts. So we need a testnet for that, and we're going to have that testnet locally. As you can see here, this software offers you a list of Ethereum addresses here that you can use to send transactions to and from. You have the addresses and you also have the private keys. Remember that these are like passwords. You should not be showing this to anyone when you are actually working in the real world. This is a testnet, so it doesn't really matter, but be very careful with this stuff. Never ever show your private keys and be careful when you are developing with those private keys. So we're here in Visual Studio Code, and we're going to take a look at our .env file, which is our configurations. So we're creating several environment variables here. Some of them we're going to use for testing, some of them we're going to use in our code. So the first one is we have node provider local, which is the one that we are using to bring Ganache into the table. We are creating we're using two addresses that we are copying from our local node as well, and we're using two private keys that we're copying from our local node. So that is what we have in relation to environment variables. Then we also created this file here, which has the main kind of a scaffolding that we need to start building and start interacting with the Ethereum blockchain in our testing environment. So let's get to it. We are going to go through it a little bit just by reading it right now, because we have done this part in the previous videos. So we have the import.os. This is from bringing the environment variables to our code. Then we have the .env, which is the library that allows us to read our .env file that we have here. And we have the Web3 library. Those are some basic components that we need. We also are using the .env library to load the local variables. Then we are going to put in the node provider the environment variable that we call node provider local, which we created in our .env file, and we're creating our connection to the Web3 network. And right now we're using a node that is running locally in our machine. Finally, we have our function here that we use to test the connection. So let's do that right now. We import our module, and then we ask, are we connected? And then we are connected, so everything is working properly. Now we are going to start working with the transactions, right? So for this, we're going to first start creating the skeleton of the function that we might need to interact with the local Ethereum network and send a transaction. So we're going to define a function here that we are going to call transfer ETH, And this function is going to take the following parameters. We're going to take a sender, we're going to take a receiver, we're going to take a signature, which is going to be a private key, and we're going to take an amount of ETH, right? So we have that function there. Now, when we send a transaction, we need to create a little dictionary that has a JSON-like structure. It's a Python object. And we're going to send that one over. We're going to first sign it and then send it to the node. So let's do that. We start by creating the dictionary. So we're going to call that one transaction body. And transaction body will have the following elements. We are going to define unknowns. And for now, we are going to just keep it open there, because we are going to have to write another function to retrieve unknowns. Then we're going to have a 2, which is the receiver, so that when we can fill up right now, we have a receiver. Let's remember to put a comma after each of these elements. Then we have a value, and this value, it's going to be the amount, but we need, if the user of this function is sending ETH, we have to actually translate it from two-way, not from way, two-way, because the network works in way. So we are going to take the value that we had here, which is the amount ETH, and we're going to say that that one is Ether, and we want to transform that value to way. So that's it. That's the other element that we are taking. Now let's continue. Besides the value, we need to send two other things, which is the gas. This is an abstract concept. Is the amount of units. Think of it as liters of gasoline or gallons of gasoline that you need to run a car. So the Ethereum network runs on gas, and the gas is ETH. So ETH is the gasoline, but gas is the units of measure. And the price of gas, like the price of gasoline, would vary. So we need a gas price. And this depends on what is the conditions of the network currently. So we're going to have a couple of variables here that we are going to define. For now, we are going to leave them blank. So we have our dictionary here. Then, after we have that dictionary, we need to have something else, which is we are going to sign a transaction. So we're going to call this variable sign a transaction. And that is going to be equal to Web3 connection ETH account sign transaction, and we are going to sign the transaction body that we have here, our dictionary, with the signature. So this is the moment that we're using our signature. Then we are going to send that transaction over. For that, we're going to call a actual method, but we are going to store the results of that method in a variable, so we're able to retrieve something when we send transaction. So we're going to send ETH send raw transaction, and we are going to do signed transaction raw transaction. And basically what we are doing here is that the transaction that we sign here, we are sending the raw value of that one, and that's what we are sending to the blockchain. Then after this function finishes running, we're going to return a value which we're going to call result. We finished the body of our transaction, but there are some elements here that we have not actually completed yet. So we are going to start with the ones that are easier to solve, which is the gas. And we're going to create a global variable. So we're going to call global gas, and this is going to be equal to something, and then we're going to have another one that we're going to call global gas price, and that's the other one. These could have been environment variables, but we're going to leave them here. So we are going to start with the gas, and we are going to put 4.5 million as the amount of gas that we are going to pay in this transaction. Is it high? Is it low? Well, that depends on the conditions of the computation of the network. This is a good kind of like a rule of thumb for testing. Now let's go, and we need also to define the price. So for the price, we are going to send an amount of Quay, not Way, Quay. Quay is another division of Ethereum, another fraction of Ethereum that is commonly used to define the gas prices. So we're going to send 8 Quay, and we are going to send it as in this fashion. So we're transforming this 8 Quay to Way. So that's it. We define the gas prices, which are our transaction costs. So we're going to put global gas, and this one is equal to global gas price. Beautiful, we have that. Now that we have that, we are going to define the other element that we're missing, which is the knowns. We are going to do it in the following ways. We're going to define a function that we're going to call getKnowns, and this function is going to get an ETH address, and this ETH address will be the one that we are going to track to get the correlative of the transactions that have run through that address, and that's going to be our sender in all cases here. We're going to call this function inside this other function. So we're going to get return, and we're going to get Web3 connection ETH get transaction count, and we are going to get the transaction count of the ETH address that is mentioned here. So testing time. Let's do Python. We enter the Python console, we import our module, then let's test if we're connected. Are we connected? True. Now let's call all of these environment variables that we have. So we have it around here. We have transfer th, which is the environment variables, which is the name of the function, and we're calling it with all the environment variables that we define here in our dat.env. Since we are in Python console, we can use the OS library that we imported to call all of those like that, and it's a little bit easier to remember that than going and copy paste everything that we have here in the dat.env. So that's the reason we're doing it that way. Let's run it, and it doesn't work. Okay, I see. Let's check it out. It's in the get nonce, and here's the mistake. We had get block, and it should be just get transaction. So here it is. Now let's exit here, save it. Then we are going to clear it out again before entering the console once again. And right now we are going to do the same. We're going to import our module, and right now we're going to call it again. Same parameters here, and let's check. Let's go to Ganache first to see what is the status. So we have 96 ETH in address 1 and 104 in address 2. Let's do one last testing here. So let's go back and let's reverse them. So let's get everything to 100 in this one. So we are going to switch. The sender is going to be address 2. The receiver is going to be address 1. And the private key that we will need then is private key 2. And we are going to send for ETH. Let's tested, and we get our hash back. So go back to Ganache to see that everything worked, and as you see, everything is back to 100. So guys, this is the way that we interact with the Ethereum blockchain in our own local environment. And this is the basis for starting working with transactions. In the future, we are going to start working with our own smart contracts, which is going to be exciting. Thank you very much. Smash that like and subscribe to the Morales channel.